Hey guys, it's Mr. Rysz here. This is part 3 of P3. So really, hopefully it hasn't been too bad. The first section probably was a little bit longer than the second. We're going to do the third one here. So this third one here, we're just going to kind of talk about, add to our notes. So when it comes up later, we are familiar with it. But when it comes to functions, there are typically like 3 categories of elementary functions. Those are typically functions you learn in, high school, things like that. Not so much like elementary school, but not the classically trained college classes you will have. So algebraic functions are your typical polynomials or your radical or rational functions. So, like 1 over x is a rational radical, obviously like a square root, and any polynomial x cubed, x squared, those things. Trig functions, sine, cosine, tangent. I guess probably sometimes last year doing that. And then probably in algebra 2, you did exponential functions like e to the x or logs. The one thing that's nice about polynomial functions, they always follow this standard pattern. This is the fundamental theorem of algebra, is that any equation can kind of be written as a polynomial function right here, where we could have any number here for a sub n and then x to some power, where we'd always have some degree, and n would be the highest degree term, and that leading coefficient will tell us some things about it. So you can see here a 0 degree term would be like a by itself, just like 3. A first degree term would be a linear function like 3x plus 5. Second degree term would be a quadratic 3x squared plus 5x plus 6, and so on and so forth. So the one thing I want to make sure you guys know is whether the function is even or odd degree, and whether the leading coefficient is positive or negative, and how that affects the graph. So let's just kind of review here. Make sure you have this information remembered. So I'm going to make 4 graphs here. Why is this just the worst of writing? Okay, we'll get better. Okay, so let's think. We're going to think about even degree. So this would be like an x squared, x to the 6th, x to anything. Okay, what's going to happen here? If we have a sub n is a greater than 0 number, so that'd be a positive number, 4, 5, 6, those are all greater than 0. How would this graph look like? Well, that graph would start up high, like 3x squared would start up high and end up high. So if we have an even degree, they start up high, end up high. Now, if a sub n, the starting number was at less than 0, so like a negative 2x squared, a negative 3x to the 18th power, something like that, it would start down low, end down low. Now, we don't know what's going on in the middle. I mean, technically, it could be like start down low, up, jump, jump, a bunch of things down here, and then it would start down low, end down low. We just know we're talking about the starting location, starting and finishing here. Okay, next we have odd degrees. So this would be just like a plain old x or an x cubed, something like that. What's going to go on? If it's positive, that means like an x cubed starts down low, does some wiggle squiggles here, ends up high. So if it's positive, we start negative with our negative x's, we end positive with our positive x's. Makes sense. And then if we have a negative leading coefficient, it's the opposite of that. The negative values would make a positive answer up high. Our positive x would make a negative answer down low. Okay. So now let's focus on what today's CYU is going to be over. Composite functions. So composite functions are functions inside of another function. So the one thing that the range of the one function, inside function, becomes the domain of the next function. So let's just make sure we know and remember how to write these. So if I have choice A here, find f of g, remember that's the same as f of g of x. So that means we're going to take g of x and we're going to plug it into the f of x, and that would be 2 cosine x minus 3, or just 2 cosine x minus 3. Okay, that's all we're doing here. We're just going to write them. We might evaluate them. Now, g of f of x is the opposite, meaning we're going to take the f of x and plug it into the g. And so that's just going to be cosine of 2x minus 3. And because the rules with the cosine function, we can't distribute or anything like that, and we just leave it like so. Okay. So how does that affect us out? We'll look at, maybe we'll go through a CYU problem to help us. Okay, so hopefully that isn't too bad. I think most people do pretty well on that. All right, last thing here is even or odd functions. This might be something new to you, so we're going to keep this really brief. It's just going to be multiple choice questions, and I don't like to overkill this. But an even function is when you have the negative x, you plug it in and it becomes the original function. Like x squared is an even function, because if I take a negative and put it inside of the x squared, it still becomes a positive x squared in the end. An odd function is when we have the negative x, if we plug it in and simplify, it becomes a negative version of the original function. So like x cubed is odd, because if I take a negative and put it inside the x cubed, it would make the whole thing negative, and we can simplify it that way. So kind of like when we did the symmetry problems. So let's go through these two here. All right, are they even or are they odd? So let's first check with A here. We got, let's find f of negative x. What would negative x cubed minus negative x become? Is there a way we could simplify? Can we get back to the original, or could we have just a negative version of the original? So negative x cubed would be a negative, that would just be a negative x cubed, and minus negative x would be a plus x. Now that isn't the same thing that we started with, so we can definitely say this is not even. Now potentially is this odd? If I factor out a negative, so this would become a positive x cubed and then become a minus x, we do have a negative, and that is the original function, right? That is f of x right there. So this is a odd function. Now there is a chance that it's neither. In fact, a lot of functions are neither. They're neither even or odd. All right, next let's talk about g of x. Well, actually let's talk about g of negative x. So what's 1 plus cosine of negative x? Okay, so it's not as easy as the other one, but let's think. You know, do we have a unit circle here we want to pull up? Maybe look at the cosine. I'm gonna pull up a unit circle. Unit circle. I probably should, you know, I always do this. I should have one just saved up, but I just Google. Google. Let's look here. It's kind of hard to see on mine, but cosine. Let's look at cosine is the x and see how it changes. If I go to pi over 3, it's 1/2. Now negative pi over 3 is on the opposite side here, is also 1/2. Double check it over here on this side here. If I go to 5 pi over 6, is that negative radical 3 over 2? If I go the other way, still negative. So the negative 1 is always the same as the positive 1. So what does that mean for our answer here is that even though it is a cosine of negative x, we would get the exact same answer of cosine of positive x. Now, is that answer here the same thing as what we started with? Yes, it is here. So that is an even function. Okay. So this, I believe, wraps up our notes. Yeah, there's some homework here if we were back to doing things from the book, but we're not this year because we're getting better. Let's look at the CYU to help you guys out with the problem. So today's CYU, you can see you have problems like this one here. Find f of g of 1. Okay, so something like that. We're going to plug 1 into g. So let's see, 1 squared minus 1 is 0. And then we're going to take that answer and plug it into f. What's the square root of 0? That'd be 0. So match those up. So you got that one and that one. Okay, so here's the problem you guys might have some trouble with. I just want to help you out here, and I'm going to probably draw on this. So find f of g of 3. So first off, g of 3, to find it, this is the g function here. I'm going to go over to 3 and find out where it is. It is located at 1. So really, f of g of 3 is the same thing. I know g of 3 is located at 1. So it's asking me, okay, what's f of 1? Go to 1 here. Where is that at? That is up 3. So the answer for that one would be 3. Oh, you can't see it there. I'll put it here. 3. All right, next problem here. What is g of f of 2? So I'm going to start in the middle here. I'm going to ignore the g part. what is f of 2? So I'll go over 2. Where is the f? That is at 1, right? F of 2 is at 1. So now I have to answer the question, what's g of 1? So I'm going to go over 1. Where's g? At -2. And one more just to help you out here. All right, g of f of 5. So I'm going to ignore the g part. I'm going to just start in the middle, f of 5. So I'm going to go over to 5. 1, 2, 3, 4, 5. Where's the f function? It is down here at, I'd say, -5. All right, so now we have to answer what is g of -5. So I'm going to go over to -5. 1, 2, 3, 4, -5. Ooh, there is no g over here at -5. So this one is undefined or just does not exist. All right, so hopefully this helps you guys out with the problems. You guys should be good with the rest. Yeah, even odds. All right, that ends P3. P4 we'll just spend one day on. So I think you guys are doing good. We'll end this video as always. You guys have a great day. See you next time.